Decide not to die. Decide not to get hurt at work today. That statement by itself sounds pretty ludicrous, but in fact, it cuts to the chase of safety in the workplace, because most accidents start as a thought in the mind of one worker that later places them and maybe us, maybe you, maybe me in harm's way. A thought they were thinking. That's what today is about. I want you to think, to sit back and take a deep breath and think.
So did everybody hear that? Hello, everybody. It's John Pushkar, and I'm here today with another episode about being safe in the world of fuels and fired equipment. And I actually have that man, a good friend of mine, Sean P. George, here to be interviewed to talk about safety in the workplace, to talk about his think concept. And then we're actually going to together kind of go through the 6 steps of safe gas piping repairs. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. So Sean, hello, welcome. Glad you could make it today.
Good afternoon, John. Thanks for having me. Good to see you.
Likewise. It's been too long. And in today's world, I was glad when I got a hold of you. There was actually a warm body that was breathing and still functional on the other end, because as we know, you never know that in today's world, right?
Absolutely. I understand that.
So Sean, I'm going to try to do a little bit of an intro for you, but you could probably do the best intro of yourself. I know that you've been a part of the Steam Fitters for a long time. You've traveled all over the world delivering your message about think and safety in the workplace. Could you tell us a little bit about yourself? And then I'm also going to show folks your website, and we'll talk about how people can get a hold of you.
Sure. I'm currently 65 years old, and I spent the 40 years with the Steam Fitters. I no longer work in the field. About 3 or 4 years ago, I discontinued field work simply because I could no longer do it. It was about 19 years ago when I started the Sean George presentations and began to deliver the 50-minute to 1-hour message that I'm now known for. I really didn't have any idea where it would go or if it would go anywhere at the time, but it came as a result of my having been asked to speak to a group of Boilermakers on the job that I was on at the time. The steward on that job said, "I've got a lot of young Boilermakers here. If you tell them what happened to you, we need to wake them up. I think it would be helpful." And that was how this began. You'd mentioned I have been all over the world. I got to go to Japan for the Marine Corps, which was really exciting. That was the highlight of my career. And I have been all over the States and continue to. Next week, I'll be in New York. And the next 4 weeks, I'll be on the road. Pandemic has made things crazy. Obviously, things are still kind of in flux. But all told, things are going very well right now for me.
Fantastic. Let me try to get your website up here. So Sean, you talked about going to Japan. I could see that was for the Marine Corps. Quite impressive. My youngest son is I shouldn't say former Marine, because once a Marine, always a Marine, but this is Sean's website, www.seanpgeorge.com. And there's a phone number there, 412-613-1986. And Sean, one of the things I've showed people a lot in the past 15 to 20 years is a presentation that you've done that goes 55 minutes. And I can just about recite every word of it. And it's what we started out this presentation, this episode with, and it's your famous Think video. It chronicles something that happened to you back in 1975 that, frankly, you weren't supposed to live through, right? I mean, you were burned over 65% of your body. It's a miracle that you're here. I don't want to rehash all that right here. Folks, I highly recommend you pick up that DVD, Decide Not to Die. It's full of his story and wonderful other stories that Sean's become known for. Very, very poignant. Sean's an excellent communicator, especially when it comes to people who work in the field, because he's done a lot of that. Sean, what I wanted to do is I kind of wanted to go through 6 steps to a safe gas piping repair. And I thought you and I could kind of go through different parts of that, and we can add some realism to that, because, you know, I've done it from like a design and engineering perspective, and you've done it from a guy who's actually been there turning wrenches, welding perspective.
Right.
So folks, what we're going to do here today is we're going to talk through these 6 steps, and we're going to add in a few little interesting stories as we go. So the first step is be shutoffs and isolation. And here we're talking about finding valves that work. We're talking about lockout, tagout for gas piping systems. And Sean, it's been my experience that people in the electrical world do an excellent job of this. It's, you know, seems like when all the lockout, tagout rules were written, they had in mind people throwing locks on electrical disconnects.
Right.
Does it really work that smoothly in the field for piping systems? Give me a taste of that.
You know, for piping systems, it's really just a question of closing a valve or two. One of the issues, though, is oftentimes the systems you're working on are antiquated, and you cannot get an effective, a positive shutoff, and that can lead to a lot of problems, a lot of issues. And there's actually an incident that occurred here in Pittsburgh that comes to mind, where that was exactly what happened. Because of the age of the valve, it didn't hold. So this is an issue.
So are you talking about that there is like debris in the pipe that the valve's trying to seat against?
So the age of these valves, and sometimes the valves just don't work. They're so old and they've never been rehearsed, never been opened and closed in years, that for whatever reason, they just don't give you a positive shutoff.
And you know what? You bring up a good point. Let me throw in that little tip or trick, because a few years ago, we did an isolation, purging, and gas reintroduction program for US Steel for all their facilities. And an important part of that was rehearsal. It's funny you bring that word up, because what we learned there was you don't actually go there and close a valve and shut down a system and, you know, interrupt your operations, but you actually might move the handle a little bit just to make sure that the valve isn't seized in position.
Right.
And likewise, you may take a really good hard look at some of the bolts you're going to be removing. And sometimes if there's, you know, 10, 12 bolts on a flange, you try 1 or 2 of them just to make sure that you're not going to be into a real problem when you're trying to disassemble.
That absolutely. Sometimes people will spray the bolts ahead of time, 24 to 48 hours with the penetrating agent to loosen them up so they know that they'll be able to get them off.
So this rehearsal part, this pre-job planning, can't stress that enough. Is that right?
Correct. Absolutely.
Great. So then the second part of this, folks, is this pre-repair purging or venting. Venting is the removal of the pressurized gas that might be in the line. And then purging is actually using an inert substance and pushing that material out. And there's a pre-repair purge, purging something out of service, and then there's purging something into service. But a key issue with when you're going to be venting or purging is to make sure the stuff goes out of a building. The incident that happened to you involved gas coming into a building, but you weren't alone. The ConAgra incident that ended up killing a number of people was gas being released into a building. Been many, many, many accidents. So NFPA 54 now, the National Fuel Gas Code, says you're not supposed to release gas into buildings. So how's that work, Sean? You're on a job. Sometimes there's pressure. Sometimes people are in a hurry. Sometimes there's a feeling of maybe I'm not the senior guy on the job and somebody else is kind of directing it, and gee, they probably know what they're doing. What do you say to that?
First of all, I say that, the procedures have been written that will allow us to do that safely, but if we don't use them, they're all for naught. And one of the things back in 1975, the accident I was involved in, even though there were combustible gas detectors available, there were none on the job site. So at that point, we attempted to vent that system to the outside air. We couldn't find a hose to do that, and that's why we ended up venting directly into the boiler room. Today, people do use 4 gas monitors to make sure that they have or do not have gas.
How might you be getting gas out of the building?
Good question. Well, first and foremost, they would look for a connection point outside, so that this could all be done outside and you don't have to come in anyways. And the other way is simply to use whatever apparatus you need, a hose or some temporary piping, to vent the gas to the outside air so it's dissipated. And of course, if you're doing that, you have to have an area roped off with caution tape so that no one enters that zone where that gas will be flowing into the atmosphere. Does it make sense?
Absolutely. And I guess, here's where we're, when we're shutting off and isolating, nothing tremendously dangerous has happened yet, right? But this
Correct.
is finally now the part of the job where the rubber's starting to hit the road, where we're actually now got some real hazards that could occur. And maybe if you got a word or two for some of the young guys, because this is where you could get peer pressured into saying nothing and seeing something really bad happen. So how does that work? When you're part of a crew, maybe you're not the senior guy. Have you ever been in that situation where politically you felt like maybe I shouldn't say anything? Do you have any thoughts for people who may not be the senior guy, but they feel like they should say something?
Absolutely. And this is a predicament that happens over and over, and it plays out still today in the construction field. All I can say is this. When I ask the question, what value do you place on your life? And, when you make a decision like this, if it's unpopular, if you're one of 6 people in a crew and you're the only one saying this isn't right, that can have a very isolating feeling on you. And it can be difficult to deal with, not easy to do. And I've been asked, how do you do that? And I don't have an answer for that. This is a challenge for some people. For others, it's not. It can be difficult, though. But again, I tell people to retreat to this thought. If things go wrong and my life changed, is it worth it? So, speaking up can be a challenge, but better to be safe than sorry, because once the accident's set in motion, it's already too late.
And I tell people that I would rather be called an idiot, a fool, a dummy, a sissy 1,000 times than get hurt or see anybody else get hurt. I'd rather live with being stigmatized as being the guy who cries wolf all the time. And I got to tell you, frankly, I've got thrown out of a couple of places for crying wolf, and I'm okay with it. There was a time I was working over in the Caribbean, and there was an oil-fired boiler, and they had the burner apart, and they had oil lines that were pressurized with ball valves that were closed, but no plugs in the end of the ball valves. If somebody would have walked by and accidentally hit it, there would have been oil spraying out. I asked people a number of times to please stop. Let's put plugs in the ends of those valves. Nobody did it. I had to call the corporate office, tell them what was going on, and tell them I was uncomfortable. The plant manager came down then and asked me to pack up my stuff and leave because I had poor communication skills, because I should have went to the plant manager's office. Maybe I should have. I thought I had told everyone around me who was in charge, but you know what? I'm good with that. I didn't have to watch anybody get hurt. All I had to do was leave a project. So good to get your perspective, and hopefully we've encouraged someone else to be okay to speak up at some point.
I remembered a job I was on years ago where we were working in a pipe rack, 3 of us, and we were welding pipe supports onto some I-beams. And we got into an area where tank cars were being loaded, and there were huge flammable signs all over and explosion risk signs. And there was an open tank car beneath us, and one of the fellows with me started to get ready to strike up an arc to weld. I told him to hold off, and they did. They held off, and I went and talked to my foreman, and basically they didn't care. And the foreman actually did listen to me. And when we got back to the area, though, they'd already done the weld. So these guys had just already done the weld, and they had the attitude of, well, look what Sean's been through. He's a little bit anxious about this kind of stuff. I knew that what they were doing was wrong, and I knew how quickly it could go wrong. But people just get complacent. And, I think their mindset was, this is not even a 5-minute weld. We'll be in and out of here so fast. And I didn't confront them, but I remember they sent me home that day because I was so upset. The foreman said, why don't you just take the rest of the day off? And I did, but I never forgot about that. I mean, and both of these guys were intelligent, good mechanics, but these are the things that happen. People get complacent, they take shortcuts, and they usually get away with it, unfortunately. And that just emboldens them to do it again.
Well, funny you should say that. That's right on cue. Because the next part of the piping repair process is to actually make the repair and do the weld. And this segues perfectly into a story that you've told a million times. You've told it to me a million times because I've listened to it on your Think video. Can you tell us about complacency and the welder who had the lighter in his pocket?
Right. Well,
great story, and it fits right in here.
I always talk, when I talk, especially to young folks, I say, you go out in the job and you're anxious, when you first go out, and it's actually a good thing because you're a little nervous. Your eyes are constantly looking around. And as time goes on, you begin to get comfortable in the environment. You spend a lot of hours there, and the months go by, you begin to get comfortable, and then you might get confident. And sometimes that confidence turns into a cocky attitude, or just boredom, and that can lead to complacency. I've seen it in the field numerous times, but the story that you're referring to was shortly after the situation I was in, the accident. I was called to visit a man in the burn unit at a hospital here in Pittsburgh. And I went in to talk to the fellow, nice guy. He was in his early 30s, liked him as soon as I met him. But he explained to me that he was welding in the fab shop, and he'd been there for 4 years. He said one day he was, welding, putting the cover pass on, and he thought that the overhead crane hit him with a load because he got knocked off the box he was sitting on. Then he realized that he was on fire, and he quickly figured out that a spark had hit the butane lighter that was in his shirt pocket. The interesting thing was, he said, Sean, I carried that thing there for years without incident, and I don't know what was different that day, but something changed, something was different. And after all those years of getting away with it, then that one day he didn't. And again, this was when he was in the burn unit. But I liked the fella, and I agreed that I'd go back and visit him a couple of days later. Picked up some magazines to take him. And before I went in, I called to make sure it was okay to go in. And they said, Sean, that's very thoughtful of you, but we lost him. He died last night. And I was shocked. I mean, a little butane lighter, little innocuous thing that we use every day, caused this man to die. And the bad part of this was he got away with it for too long and decided that it wasn't a problem, but it ended up, he got complacent because he got away with it for a while. Even though he had a veritable bomb in his pocket, he thought he was okay, and he thought wrong, and it cost him his life.
So just like the guys you were working with on the tank car, just like you said, like most of the time you get away with this stuff, right?
Right. Absolutely.
Yeah. So it's just not worth gambling with your life, though. So pressure testing and leak checking, folks, are two different things. Leak check's kind of an informal thing. There's really no standards I know of for pressures you have to hold and times. But when you pressure test something, NFPA 54 tells you how long to hold at what pressure. ASME B31.1 and B31.3, the steam pressure piping codes, they tell you what pressure to hold and for how long. But What I really want to get at with you, Sean, when it comes to pressure testing is how very, very dangerous it could be, especially when you're using like compressed air or nitrogen. And that's called a pneumatic pressure test when you're using a compressible gas. I've seen and heard of pipe joints coming apart. There's a lot of stored energy. If a fitting or something comes off and you got a bunch of compressed air in there, that fitting comes off like a rifle slug. There have been many people killed doing pressure tests. You got any thoughts or cautions for us about pressure tests?
The one that comes to mind was, in fact, not gas, but water. And a system was filled with water and pressure was pumped up and then held overnight. And at the end of that system, at the end of a piping run, was a valve, but it had what's called a Dutchman. It had another small section of pipe running out the back end of it, about 3 feet, and then an end cap on the end. Well, someone at night closed that valve, and unbeknownst to anyone else, the pressure test passed. So they bled the system down, got all the water out. But remember, that valve was closed. So that little 3-foot length of pipe downstream of that valve was still pressurized. Not knowing this, an apprentice went up to remove that end cap. It was bolted on. And when he removed the bolt, the end cap flew off, hit him in the head and killed him. So again, it's a deal where, the communication is huge. It has to be, you have to be on top of your game and get everybody in the loop. In a case like that, somebody was in there that shouldn't have been, closed the valve, seems harmless enough. No one knew, and then ended up costing a young man his life. So it's really important to have procedures in place, to have a game plan, and to stick with it. You can have the best standards written in the country, but if you don't use them, they're useless.
Well, and so a couple of things you point out, you can have all the documents and paper and books and engineers standing around, but if all that isn't communicated and isn't into the head of the guy that's actually removing the bolts, it's all over. It's meaningless.
Correct.
And the other thing I tell people about pressure tests is, I tell them, you know what? It's not a spectator sport.
Right.
That's not something where pressure test is going on and you go, hey, can I just hang out with you guys and watch? You just did that, and starting up equipment are times like it's better if you're somewhere else if you don't have to be there.
Absolutely. Better safe than sorry, really, as in so many cases in the field.
Yeah. So we've pressure tested it. Hey, good news, it held. Now we've got this situation where we've got this piping system that's full of air. We got to bring gas in. And you don't want to bring gas into a system that's full of air, because at some point you mix the gas in the air, you have a flammable mixture.
Right.
So you first put in nitrogen, that's the purging into service. We put nitrogen in to push the air out. Now we bring gas in on top of the nitrogen. And so then we have the whole situation, and I'm kind of blending in the post-repair purge and the gas reintroduction, the 6th step. And now we have the problem that, you have to get, by code, 90% gas at the endpoint, at the equipment isolation valve, so that you can actually light a burner.
Right.
So that takes a special meter, because the meter has to be able to read percent methane in an oxygen deficient environment. So it's not a typical 4-gas meter that'll work. So you do need some special equipment to do this right.
Correct.
What we don't want you to do is to keep trying to light burners over and over and over again. That's what led to the tragedy at the ConAgra Garner, North Carolina Slim Jim plant site. And there's a great video about that. I'm putting a link to it in the comments section of this episode. It's by the U.S. Chemical Safety Board. It'll tell you all about that and exactly what I'm covering here. And Sean, that was also something that led to the incident that you were involved in a number of years ago.
Correct. I was just going to say, the correct way to do this, using nitrogen, it's an inert gas. You use it to isolate the air in the system from the gas. But again, nitrogen is dangerous also. And I recall an incident where someone had breathing air and they hooked up to the wrong line in a plant, and they ended up 3 breaths of nitrogen, and it killed them. So you're dealing with something that's seen as innocuous and inert, and yet it's dangerous. And again, you have a monitor so that you can know when the nitrogen is no longer coming out or when it's present. You may need more than one monitor. Make sense?
Makes sense. And I try to tell people, if it didn't light after 2 starts, stop.
Right.
Stop. Go get somebody who really is a combustion or burner expert or an instrument tech. Make sure you're following the procedures. Throw the penalty flag. Don't stand there trying to start over and over and over again, because every time you do that, you are releasing gas into the firing chamber. If the purge isn't working right, you can end up with some very bad results.
Absolutely.
Sean, you talked about a 4-gas meter kind of as PPE when you're doing one of these gas piping jobs.
Mm-hmm.
The other PPE, you might need flame resistant clothing if you're doing welding, safety glasses, hard hat, might be a number of pieces of important PPE you need. And you're so good at telling stories, I want to get one more story out of you. You talk about PPE in a very effective manner when you talk about the guy who was the iron worker who climbed up with the harness. Let's close this episode by you kind of, can you tell us that story?
Sure. There was a poker run, which is when a bunch of motorcycles get together. And it's a charity thing, a charity event. There was an iron worker that had been killed, so they did a poker run. Everyone had their motorcycles to raise money in his honor. And when I got there, someone who knew me said, "Hey, there's a fellow here that you should talk to." And they introduced me. And the guy knew me, and he'd heard my story. So he started to tell me his story. He was a connector. These are the iron workers that do the really high work. They, get on the terminal end of steel. It's high in the air. Wait for the crane to lower the next piece of steel down to bolt it up. Dangerous work. But he said, "Sean, I'm a connector." And they were a very proud bunch. And he said, "I never used fall protection." And there was some machismo involved there. He admitted to it. He said, "But work was slow, and the only company hiring insisted I use PPE, a harness and a lanyard, fall protection." He said, "I didn't have a choice. I needed the paycheck." So he went to work for the company. They gave him training. He said the day of the incident, he was about 80 feet in the air welding lugs on structural steel. No problem. Worked through the morning, broke for coffee, went up, had a coffee, and went back to work. And he said that's when it happened. And he said, it's funny because he fell. And I asked him, "Wow, what was that like?" And his response was interesting. He said, "I don't know. It happened so quickly. I never had a chance to respond. And I really didn't even realize what was happening." He said, "I didn't know what had happened until I was dangling by the lanyard, looking up at the people above me." But that gentleman ended up climbing out of that hole, turned in his harness, put a new one on, and went back to work. And it was then that his family showed up, wife and 2 children. And that's when the PPE thing crystallized for me, because I always had reservations about whether or not this was effective. And to be honest, I didn't care for it. It was cumbersome. It was hot in the summer. I was the guy that just didn't have much use for it. But I realized when I saw his wife and children and how happy they were, how different this scenario would be had he not had that fall protection on. And in fact, he had become an advocate for safety and for PPE. So this is when things changed for me, when I recognized and realized, okay, somebody had to give their life or perhaps get hurt in order to win us the right to use this stuff. But we have to use it and use it properly, the way it was designed to be used. That was a day I'll never forget.
Appreciate it. So Sean, I really appreciate you being here. It was great to see you again and to hear your stories again and to actually hear them live. I hear little twists and nuances every time you go through one of those. What I'd like to close with is just a kind of a feeling I have. I know it's a feeling you have. It might be more than a feeling. It's a little bit of a frustration. I don't know whether talking about it's going to motivate a lot of people, but let's try, okay? You mentioned something. You said that luckily no one had to have been sacrificed with their life or with a traumatic injury in that case where the gentleman slipped off and, the company provided a bunch of PPE.
Right.
I got to tell you personally, out of the 25 biggest clients I've ever had, I got to tell you, Sean, after 40 years of doing this, there's only a handful who came to me where there was no fatality, no traumatic injury, and said, wow, that's really good stuff. We need to start testing all the safety devices on our equipment. We need to start training people about boiler safety or fired equipment safety. And I've always hated that, but I guess it's human nature. We were talking earlier in the work we did leading up to this, that I look at it as that Bible story with, St. Thomas having to put his hand in the side of Jesus to actually feel the hole. You feel some of that? Have you experienced the same sort of thing?
Yeah, absolutely. It's hindsight's 2020, and so many people that I deal with have come to me because of that reason, because of a fatality or an accident. It's true that a lot of the standards we have today and the PPE that we use are a result of accidents that happened 10, 20, 30, 100 years ago. Here's a good example. I jumped out of planes for 7 years for fun, skydiving. And the safest drop zone to jump on would be one that had a recent fatality, because when you'd set foot on the grounds, they were doing everything correctly. Most of them don't. Most drop zones you can walk onto and find some little thing, or sometimes a big thing that isn't right. If you walk onto a drop zone where someone has died recently, things are shipshape. They run much more tightly. Make sense?
Makes sense. So I think the overall message from us folks here to close is the amount of grief and the impact it has on people and your organization's culture, even in just little ways, when there's a fatality or a serious injury. You use the word palpable. It's palpable, and it'll impact you for years and years and years to come. Much easier to address it now, to reinforce the message, either in what Sean has to say or what I have to say or what we both have to say. Once again, Sean, I really appreciate you being here. Glad to reconnect. And if you wouldn't mind, give us that website again one more time, and give us your phone number again one more time.
I'd be happy to, John. It's www.sean, SEANP as in Patrick, George.com. The phone number is 412-613-1986.
Great. Thanks again, and good health to you.
Thank you, John. Great to see you.
Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services online school, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.